So today, looking at bottlenecks, we'll actually touch on three of the same topics that Peter just spoke about: system complexity, people, and infrastructure. Specifically, we're going to be looking at what kind of elements lead to bottlenecks in a single node, what happens when people form the bottlenecks, how to identify those bottlenecks ahead of time and what to do about them, and how to deal with the law of diminishing returns and how it will require you to change your scaling strategies as you move forward. I suppose I skipped a step there. Who am I? Well, I am Rodney Nissen. By day, I am a senior Atlassian engineer at Coyote Creek Consulting, which is just a fancy way of saying consultant. I am also an Atlassian community leader and certified master, and I've been working with the Atlassian toolset for about 7 years now. However, by night, I am the blogger known as the Jira Guy. I give out weekly tips, tricks, and how-tos on my blog to help you get the most out of your Jira instance, and maybe I fight crime, maybe I don't. So what is a bottleneck? Well, Merriam-Webster has various definitions for it depending on your situation. However, the one we're interested in is 2A, someone or something that retards or halts free movement or progress. We're talking about Jira and we're talking about bottlenecks. What it robs us is performance, and how I like to think of performance is how fast can a user get something done. When you're at a small scale, just starting out, these bottlenecks like to hide. They're not easy to spot, but as you scale, they'll make themselves more and more apparent and rob more and more of your performance. Hence why it's essential to find them early and root them out. And bottlenecks are actually not limited to just the technical system. Your people and processes can cause bottlenecks too, as we'll discuss. But first off, my specialty is system administration, so we're going to look at the system. The first place I like to look at a system when I'm trying to figure out where a bottleneck is the CPU. It's the easiest to do something about, and it's also the easiest to identify. Tools I'll use, depending on my platform, is Task Manager for Windows, and either Top or HTOP, depending on availability for Linux. Task Manager for Windows allows you to see not only CPU, but disk usage and network, which means it can be invaluable for identifying a couple of potential bottlenecks quickly. However, Top does give you some of the same information, but what I specifically focus in on when I'm using Top on Linux are the percent CPUs. They're actually broken down into different categories, and the four I specifically look at are US, which is user CPU time, where the Jira process lives; SY, system CPU time, or how much time the kernel is taking for itself; idle percent, or how much the processor is just sitting idle; and WA, which is time the CPU waits on disk, which may hint that you're actually dealing with the disk speed issue rather than a CPU issue. No matter what tool you're using, what platform you're on, your Jira process should never use more than 80% of your process. If it does, you're likely facing a CPU bottleneck and you need to do something about it. Well, what can you do? Well, first instinct is always, especially on a virtual machine, is to add more CPUs, and that might actually be a good call. However, on a VM, you do need to be aware of a potential problem here. The way most hypervisor work is they'll actually wait to allocate a cycle to a VM until they have the number of CPUs assigned to that VM free. So if you have 8 CPUs assigned to the VM, the hypervisor will wait until there's 8 cores available to process that. 16, you'll have to wait for 16, so on and so forth. So the more CPUs you add to a VM, the more things have to line up perfectly before it could take a step. And if you have more CPUs assigned to a VM than are actually physically there, you start running into problems. Here, especially on Azure AWS, I start looking at quality versus quantity. It might be worthwhile to upgrade to a tier or host that has a higher CPU speed. That way you still get more cycles for the same CPU count. The second place I tend to look for a bottleneck, because it's again relatively easy to do something about, is heat memory. Now, heat memory tuning is an art. It is definitely more than a science. Atlassian gave a great talk about this at Summit a few years ago. They then posted on YouTube, which you could follow this QR code to get to. But as I said, it's a full presentation and I only have 20 minutes to get through everything here, so I'll spare you details. The first thing I will take away from their presentation though is don't bother ever changing the garbage collection method. The default settings Atlassian has for the garbage collection method works for 99% of users for Jira, and really you should only consider changing it if Atlassian support tells you to, and in my 7 years they have never told me to change the garbage collection method. The one thing you can control though is how much RAM is allocated to the JVM heap. Here you kind of have to go with the Goldilocks principle. If you have too little heap memory, bad things happen, you get out of memory errors, it's not good. If you have too much, you actually spend more time waiting on garbage collection than you do processing stuff. So you also don't get the performance improvement you seek. You have to find that just right level that works, where Jira has enough to work with without having so much spends all day getting through garbage collection. So the third place I like to look, and the place that tends to hide the most bottlenecks, is disk speed. The first place you tend to see disk speed problems is when you do a reindex. Because Jira uses disk speed to access its index, it tends to show up here. But oddly enough, I've recently encountered a problem with Jira where it showed up in project creation. In the UI, the project creation would time out even though it continues on and completes in the background. This is because the disk speed was so low that it was having problems updating the index in time. Atlassian actually has a great tool for actually measuring the disk speed of your index. If you go to the QR code here, it'll actually guide you to that process and how to go through it. And your output on the system will look something like this right here. However, right here, all we have is a bunch of numbers, and what do they even mean? Well, these numbers are actually in nanoseconds, or 1/1,000,000th of a millisecond. So Atlassian gives us this chart in the document I just linked to for it, and it gives you different ways to figure out where you rank. So for the tested system on the previous system, we got 2 OKs and 2 excellents in our scores, which means our disk speed is probably sufficient for Jira to run currently. If we start seeing that dip down to the bad range for any of these, we need to start looking at maybe figure out strategies to increase this, either going to a stripe disk or faster storage, whatever the requirement may be there. The second most common place for bottlenecks to hide, and the fourth place I tend to look, is the database. Database problems tend to be most noticeable when you are reindexing or displaying issues, details, or comments. Again, reindexing being a problem here, so you have to kind of figure out if you have reindexing problems, whether it's disk speed or database, but it could be one or the other. Just like with disk speed, though, Atlassian does have a utility to test this. Again, second to last QR code, I promise. Here's a QR code to get to the documentation for this particular utility. Unlike the disk speed utility, though, they don't have a handy chart that breaks everything down for you. However, they do have some general guidelines. Ideally, you should be under 10 milliseconds for any value here in the mean column, and absolutely under anything over 20 milliseconds is considered a poor result. Again, a reminder that each millisecond is equal to 1,000,000 nanoseconds, which is measured here. So we're looking somewhere below 20 million, but preferably under 10 million. As we see on this instance, we definitely meet under 10 milliseconds for all values measured, so we're good here on this particular instance. The last place I look is networking, and I save it for last because it is the hardest to do something about. You usually have to bring in a network team to figure out how to fix a networking problem on your Jira system. Obviously, tools you'd use to figure out if you're having this problem. The first one is IT admin's go-to ping. That'll tell you how fast or how long it takes to get to the server and back to your system. This, however, is just one number. It doesn't tell you exactly what's going on there. It doesn't tell you where the problem may be in that path. It just gives you how long that overall takes. So it's a great indication if there is a problem, but it won't tell you where the problem is. Another tool I like to use for Windows is Task Manager. As I already mentioned, it's a great place to see the network utilization, figure out if you are overloading your network connection on the Jira system. Likewise, on Linux, I use IFTop, which gives you kind of the same view. It lets you see what's going on as far as bandwidth usage on a given Jira system, so you know what's going on where. So some considerations here when you're looking at networking. The first thing is location. How far away from the server are you? Unfortunately, speed of light is a cruel mistress, and we're talking on a global scale. It comes into play. You're only ever going to get so fast from halfway around the world and back. That's just the nature of the beast. So you actually have to consider, where am I and where is my server? Likewise, the interface, you need to look at the connection there. You're never going to get 10 gigabits per second out of 100 megabit pipe. It's just, it physically cannot fit through. So if you do have a network problem, how do you fix it? Well, first off, Jira should always be on the fastest connection possible. This is where you need to work with your networking team to figure out exactly how Jira is connected to the network and how to improve that. If you're already on data center and you're having problems, especially on a global scale, it might be worth considering using the CDN functionality within data center. This will kind of even out access, so people further away from the server will get a great improvement in their access to it, while the people close to it probably won't see too much benefit from CDN. So it's definitely something to consider, especially if you're supporting a global team. So we talked about the various points of the process that could be bottleneck. We need to talk, our system could be bottleneck. We can need to talk about processes. As I said, people can be a bottleneck too. A process bottleneck typically is a task that's only trusted to a few people. It's something that you're either going to fundamentally change the process or fundamentally go through a bunch of headache to hire someone else to kind of scale up. And these bottlenecks like to hide in small tasks that you don't do too often. Creating a custom field, setting up a project, retiring an account, something that you only do one or two of it at a time, and you don't realize it's a problem until you start looking at growing it. But the question I like to ask with all these processes is, it may not be a problem one or two, but what if I had to do 20 of them in a row? What if I had to do 50 or 100? Am I still able to do that and perform all my other tasks? I think this is actually best demonstrated with a story I like to call my Grim Reaper story. So the problem we were trying to solve at a company I was working for is work items would disappear when someone left. They were still assigned to the original user, which means no one was actually working on them until they became an emergency. So what do we do about it? Well, the biggest problem, secondary problem to this, is HR was very tight-lipped with who was leaving the company. They were very mindful of users' privacy, and they didn't want more people than necessary to know. However, they would entrust this data to the Jira admin because the Jira admin, being me, already had all the company's secrets in Jira. So it didn't make sense to hide even more. So the solution we came up with, the HR and the various managers, is the Jira admin, me, would go through and reassign all the outstanding issues of that user to the manager. I would then reassign all shared filters, dashboards, and then as an extra step to make sure they couldn't access the system after they left is to remove all their groups. This process took about 20 minutes per account, but given it was 3 or 4 people per month, it was maybe an hour of my time in a given month. So I did not see it as a problem, which was very much to my detriment. So when did this become a problem? As I said, scale tends to happen when you look at, can I do 100 or more of these at a time? That's exactly what happened here. We had a layoff and I had to do 150 of these accounts at once. Doing back of the envelope math, 20 minutes per account, it was about 50 hours worth of work estimated, and that actually ended up bearing out. I ended up having to postpone some other tasks. We were in the middle of upgrade testing that I couldn't do because I was doing these accounts. I had to ignore tickets about new fields and projects just because I didn't have time to do them. And these were still people's jobs. And it was very much a miserable week for me trying to undo these people's jobs. The great thing about this company is whenever we had anything happen, we always did a postmortem. What went wrong and what can we do in the future to prevent it from happening again? And in various meetings with myself and my team, we kind of figured out the problem here. We came up with 2 solutions. And if you realize just now that you may have this time bomb, it might be time to take some notes. Our first solution to consider is automation. Bring down the average time it takes per account to do these so that it's more manageable. Our problem with automation is it requires a lot of bespoke work to get Jira to recognize who each user's manager is. And we felt we didn't have enough time to, or front end time, to do all this work to save all the time on the back end. The second strategy for dealing with a process bottleneck is divestiture, trying to bring more people into the process. Here we had a heart-to-heart with HR, said, look, the managers already know their people are leaving. They either accepted the resignation or fired them. Why can't we not bring these managers into the process? HR agreed, so what we did is prepared some documentation for a manager saying, here's JQL to find all the users' outstanding issues. Here's how you do a bulk edit to reassign them to you. Here's how you file a ticket to get dashboards and filters reassigned if you need to. Here's the process. The idea here is many hands make light work. Make sure you bring more people in so that you don't have to do so much on your own. You're not the bottleneck here. This ended up working out really well. It was really accepted by the management team, and it worked well for us for the rest of my time at this company. So now we've talked about process bottlenecks, and we talked about system bottlenecks. Now we need to talk about the real demon, the law of diminishing returns. In English, basically the law of diminishing returns says you cannot just keep adding more resources to a single system and expect to get as good a performance increase out of it. At some point, you stop being able to get performance increase just by adding more stuff. So let's say you've done this. You're on a system, you've battled all the bottlenecks back, and you're still seeing performance issue. What can you do? Or there's just too much to do for a single person. What you do? Well, when you hit the law of diminishing returns, it's time to consider changing how you scale. So if you're dealing with performance bottleneck and you've hit the law of diminishing returns, one system just isn't going to cut it. You need to add more systems. This is where Jira Data Center comes in and allows you to scale out to multiple nodes, which will allow you to serve more people in a performant manner. Atlassian actually recommends you start looking at migrating to a multi-node layout for data center at about 500 concurrent users. This is when the law of diminishing returns starts hitting on single nodes. So it's time, that's the point we tend to look at. Now, as with any scaling methodology, this one does have drawbacks. First, you're adding a lot of complexity. You're adding a database server, a file share, a load balancer, multiple nodes, more things that can break. So you definitely have to keep an eye on things and make sure that everything's up to snuff when you set it up and you keep track of what's going on in all these systems. Second drawback here is cost. All these extra systems have a cost. There's license costs to consider. There's time investments to consider. So it will end up costing you more. And last drawback is law of diminishing returns has no exceptions. When you change your scaling strategy, it'll only work for so long before you have to look for a new strategy. Here, the Jira license allows you to add as many data center nodes as you want. However, all those nodes are communicating back to the database, to the file share, to each other. At a certain point, the system becomes overloaded and you have to change your scaling strategy again. So what about people? Well, here I tend to look at where things are. I like to look at the available man hours versus the work coming in, and I like to measure available man hours to 60%. I don't mean your workers are fluffing off 40% of the time. This is account for walk-ups where people ask the Jira admin questions, dealing with tickets, dealing with emergencies. 60% is the time available for projects, and always measure for the worst case scenario. Don't measure for December when everyone's out and nothing's really going on. Measure for spring and summer when the release is about to come out, everything's going crazy and you have a lot of work to do. If your amount of projects coming in outweighs the available man hours, that means it's time to hire someone. However, as with everything, there are drawbacks to this. For each person you add, there's actually additional time needed to coordinate for the larger team. This is where the law of diminishing returns sneaks back in. And at some companies, proving you need an extra person is hard. So you always have to figure out what the cost is for that and figure out whether it's worth going through that to get that extra person in. So what are the overall takeaways here? Well, bottlenecks are bad, but if you know where to look for them and know how to identify them early, they're fixable before they cause a problem. Luckily, bottlenecks become more apparent as you scale, so if you're keeping an eye on it, you can find them early and root them out. Jira's system has several points that cause bottleneck, from CPU, disk speed, database, heat memory, etc. However, people and processes can be the bottlenecks too. Law of diminishing returns here means you can only get so much out of a single system. However, once it strikes, you know you need to change your scaling strategy. So as a last note, where you could find me, I have my Linktree link here. And again, as promised, one last QR code. This is where you can find all of my social media links, blog posts, etc. Thank you. And I will pass it on to James Mullins, who will be talking about building a good foundation for the future.